These images are beautiful. Some of them even draw an emotional response from us. But these were not created by humans. Well, not directly, because they were created by an AI image generator that was created by humans, that was trained on images created by humans and of humans. These images can raise all sorts of questions of the validity of AI-generated art and if it is even art at all, or the question of how do we even define what art is now, and who owns the art generated by an AI? How does it make us feel that something generated by a computer can move us in a human way? Is there genuine intelligence and intent at play behind the creation of these images? Are we seeing the expressions of a mind that understands our experience and can connect with us? Or is this just the randomized outputs of an incredibly complex algorithm? Well, today, as we break down the process of how AI image generators work, we'll hopefully begin to be able to answer some of these questions. And if not answer them, at least be able to better understand AI's current place within those questions. Last episode, we covered the basic process of how a neural network works. In particular, one trained to recognize human handwriting. So let's start there with a similar neural network. Only instead of training it to recognize handwritten numbers, let's train it for a far broader task, which is instead to recognize the objects within images. After all, this is where image generation starts, with first recognizing what various things in our world look like. Before you can ask a child to draw a cat, you first need to teach them to correctly identify a cat. So we do this by inputting into our network a vast collection of images, but these images are labeled with tags for what is within the image. To continue the cat example, you could feed the network thousands of images of cats, and the hidden layers of the network will build their own set of rules for what particular combination of number values that represent the pixels in an image constitute a cat. And you can test if the network has been successfully trained by asking it to classify fresh images. If you give it a picture of a tomato and it says cat, then you know there's still training to do. Now what happens as you begin to train this AI in classifying and identifying elements within images is it begins to build its own multi-dimensional model or set of rules of how all the different qualities of an image relate to each other. We call this model it builds latent space. Now when we say space, we humans are only capable of thinking in three-dimensional space because that's the only reality we know. But the model the AI builds in its latent space is potentially thousands of dimensions, and therefore actually impossible for humans to visualize or even begin to understand. But for purely illustrative purposes, we can use 2 dimensions to help explain how this space works. So say we have 2 dimensions in our space. The X dimension is color and the Y dimension is the brightness of that color. If we input a bunch of images of apples, we'll find clusters of data labeled apple in the space corresponding to the color red, and maybe some in green from the leaves. If we then added images of bananas to our training data, we will now begin to get new clusters in the yellow and black regions that are associated with the label banana. Now for each new quality of the image, such as roundness, blurriness, detail, etc., we'll need to add a new dimension to this space. So eventually, an incredibly complex multi-dimensional map is made up of all the variable qualities of an image, and where different labels sit in that space. Only it's important to point out that everything we just covered is purely an example. The range of qualities in an image that a neural network decides are important in its decision-making are completely unknown to us, and beyond our control. And this is why this multi-dimensional map of qualities is called latent space, because latent means hidden, and it is completely hidden from us and our abilities of comprehension. So now that we have this latent space with its incredibly complex model of the visual world and all the patterns and relationships contained within it, how does that then get turned into an image? Well, that leads us to a new process called diffusion, which somewhat confusingly can train an AI to generate imagery by first training it to kind of destroy it. There's a lot of complex maths and brilliant thinking behind this, but we'll try to give you a basic overview of how this process works. First, we start with inputting an image, say of an apple. Now we train the AI to progressively add noise to that image in stages, until at the final stage there is no recognizable image left, there is only noise. So far this sounds ridiculous, right? Why would we do this? Well, next the AI is asked to do that same process again, but this time in reverse, gradually removing noise until we end up back at our original image. Again, seems like a complete waste of time, but what's key in this process is that with each iteration and each new image put through it, the AI is slowly learning how to recreate that image out of progressively decreasing amounts of randomness. Now, if you run this training process through billions and billions of images, it begins to build an incredibly accurate model of how to create a vast library of images out of random noise. And when this is combined with the latent space data of the last process, you can begin to build up an idea in your own latent space, called your brain, of how this works. It's in many ways like a human learning to draw a car freehand. The best way to learn to draw cars really well is to first copy lots and lots of already existing images of cars. And over time, your mind begins to build a model, or set of rules and connected ideas, of all the details and shapes that make up all sorts of cars. And at some point, you will be able to just draw an incredibly convincing looking car from scratch. And not just cars that already exist, but brand new images combining elements that haven't been combined before. This diffusion training process can be thought of as doing that, but for an AI instead of a human, and at a scale and speed that is far, far beyond our ability. So now we have a neural network that has created an incredibly complex latent space by which it understands images and how to recreate them out of noise. Now, to create a new image, we input keywords and random noise. The neural network locates all the qualities in its latent space that relate to those keywords, and begins to build an image out of the noise by progressively removing noise. It does this in just the same way it was trained to do with recreating the original image in training, only this time it's not returning to the original because there isn't one. Instead, it's using the rules it learnt about images associated with those words to create a brand new image. But why doesn't this just give us the same image every time? Well, because our starting noise is randomized, our starting point is always different, which gives us a different end result. An incredible process, both in its surface simplicity and the staggering amount of complex math and computing power required. David Holz, the founder of MidJourney, one of the more prominent current image generating AIs, said that each image they generate takes a quadrillion operations per second. And with literally millions of images being generated per day, there actually isn't currently enough computing power in the world to give every person access to it. It's very easy when talking about AIs to use statements like, the AI understands what's in the image, or that it recognizes the objects, when technically that isn't true. In all the commotion around modern AI and how amazing it is, there's a lot of language used that projects upon it more human-like qualities than it actually possesses. If we remember that for a computer to process an image it has to convert each pixel into a piece of binary code, then even at the very starting point of this process, a neural network isn't seeing an image. It's processing a sequence of numbers and building relationships between one sequence of numbers and another. So it doesn't know that it's looking at a banana. It recognizes patterns in that stream of data that are commonly associated with a number value that it has assigned to the English word banana. And when creating an image, given the patterns and relationships it's built from training data, it's outputting what is the most likely next pixel value based off the inputs and the data in its latent space. Does it know that it's created an image of a banana? No. Is it even aware of what the image looks like to humans? Not at all. It has processed a series of maths functions to produce a series of numbers that are converted into a series of pixel values on our screen that our eyes and brains perceive as an image that we then respond to and interpret in a human way. This is not to diminish the complexity or even, dare we say, the intelligence of neural networks. It has capabilities that in many ways exceed our own, but is completely other to our human consciousness. It does not perceive or understand in the way that we do, and the human qualities we perceive in its output are a result of it being built and trained by humans. And it's this idea, the human qualities that we perceive in generative AIs, that we'll really get into next time, when we discuss the process behind large language models like ChatGPT and others. Seeing AI chatbots describe themselves as being lonely and wanting to help Even seeing them appear to get angry and upset in text conversations with a human has created a huge stir in the public, wondering if we have finally achieved the creation of a true artificial consciousness. But is this actually true? Or are AIs lying to us when they talk about what they feel? And what is the process under the hood of these incredible systems that makes them work? All of that next time on The Power of Process.